Good morning, everybody. Yesterday we talked about interfaces. We said that there are interfaces are special kind of classes. Nobody calls them classes, but for the beginners, especially for people coming from C++, we maybe we can use this definition. They are not classes, but it's like calling struct classes, right? Something like that. Okay, so interfaces are special classes whose members are all for the methods the members are public and abstract. Okay, no method of an interface can be implemented. That's the idea of the interface. And if you have the data members, they all have to be public, static, and final. Okay, constant. You cannot change the fields of the interfaces. That's what we said last time, and we have seen a few examples of interface being used. After that, we said that we have this standard Java interfaces. One of them is a comparable. Well, maybe I should talk about this. I mean, up to now, we have used this keyword interface, this word interface, as a as the piece of software that is between the developer and the client of the program, right? So we said that we are designing an interface. We said that we are writing the interface, and we are keeping the interface separate from the implementation, etc. Now Java gives this interface another meaning. Okay, so interface is a special kind of class whose members, whose method members are public, abstract, and whose data members are public, static, and final. Okay, so don't confuse between these two. Okay, these two meanings are used for the word interface, and in fact, when you take the programming language course in your third year, and you will see that interface has a different meaning there too. It is a much broader meaning. So don't get surprised that we are using the same term for many different things. Okay, so this is another meaning for interface. It's a special Java concept. So we talked about the comparable. Okay, if your class implements comparable, then you have to implement this compare to method, and that compare to method compares your object with a given any object. Okay, so the compare to Java interface compare to okay, comparable has a method compare to, and I don't want to use this one. Let's go to the official documentation from Oracle. Okay, so this is compare to. All it has is a method. Okay, and it takes one object and it compares your object with the other object. Okay, and this is as simple as this. Okay, and it can throw two exceptions. Null pointer exception if the parameter that you provide is not a valid object. It's a null. It doesn't point to anything. And the second one is class cast exception. Remember what we said, the first thing that we are doing with the equals is downcasting, right? I mean, just try to cast it to my class. If I can do it, then I will compare it. Otherwise, I will throw this exception. That's what it says. Okay. That's what it says. So this is one of the standard Java interfaces, and there are many classes that implement this interface. Let's look at one of the classes actually. Let's look at one of the classes that we can, maybe year class. I don't know what that is. Okay, it looks like there is a class named year. Okay, so this year is representing the year of the calendar, I guess. Yeah, so it's just the year, and it has two static integers in it, max value, min value, and there are many methods in it, and one of them is compare to. Why? Because this year class implements okay, comparable. Okay, also there are standard Java interfaces such as temporal adjuster, and serializable. And serializable was another example of the interfaces for the Java that the book gives. Okay, so this is serializable is the second one. As you see, if you are implementing the comparable interface, then you have to provide this compare to method. Okay, then you have to provide this compare to method, and there are tons of other Java classes, standard Java classes that does that. String is another one, another class that implements it. Let's see what's other things that, okay, it is comparable, it is serializable, and it's a character sequence interface. Let's look at this one, character sequence. Okay, what is character sequence? If you are a character sequence, then you need to provide this character add characters, code points, and etc. As you see, what did we say before? We said that Java doesn't have multiple inheritance. But as you see, the class string is both a comparable and character sequence and serializable. Okay, and it extends directly from this base or superclass object, like all the other classes. Okay, but it does these three things too. Okay, so although Java doesn't support multiple inheritance, it uses the idea of multiple inheritance in many places. Even though it doesn't support it directly, but it uses this idea. So a string object is an object. Also, it is a serializable. It's a character sequence, and also it's comparable too. Good. We talked about serializable. Serializable is something like this. If you are implementing serializable interface, okay, if you are implementing serializable interface, that means that your objects can be written to disks or sent over the networks. It can be kept in a database, and etc. Okay, so that's the serializable interface. Let's look at the documentation of the serializable. You will be surprised what it defines. I will show you what methods it will include, and that's a very surprising thing, and I will ask you a question. Okay, as you see, there are many classes implementing this serializable. Okay, and where are the methods of serializable? I don't see any methods. That's the surprising part. Let me show you the code for the serializable. Okay. The code for serializable is like something like this. Interface serializable. Okay. That's it. This is the interface. It doesn't ask you to implement any methods. It doesn't define any final instance variables, static variables, etc. It doesn't define anything. But yet, okay, many classes use this one, including string and year. So what kind of an interface is this? Why do you think they are defining such an interface and lots of classes are using it? Comparable, you remember the comparable. In order to be a comparable, in order to implement the comparable, you need to implement compare to method. But for serializable, you don't have to implement anything. All you say is this. This is my new class money. Okay. Implements serializable, and I implement everything in my class, and I become a serializable class as money. Okay, so it is as simple as this. So why would I need such a thing? Any ideas?
Maybe it is like a signature to the class.
Explain that a little bit more.
If Java compiler sees it, it allows to the it allows to the write to disk or send with the network.
Yeah, exactly. Yeah, it is kind of a marker, okay? It's kind of a marker. If my money objects are serializable, then let's say there is a method void write to disk, and this method is going to void write to disk, and this method is going to have, let's say, serializable array ARR. Okay, the task of this method is to write objects to the disk, but it says that I can write only serializable objects, nothing else. Okay, so money is a serializable, string is a serializable, year is a serializable. Okay, but they don't have any elements in it. They don't have any. I mean, they don't. Those are all serializable, but they don't have. They don't have to do anything regarding their serializableness. Okay, so it is serializable is just a marker. In order to be able to call this method, I need to say that I am implementing serializable. If I don't want my objects to be serialized, written to the disk, or sent over the network, then I don't implement serializable. Okay, so I don't include this serializable in my class definition. Okay, so serializable is such an interesting interface. So interfaces are very abstract, even they are more abstract than abstract classes, and serializable is as abstract as it can get because we don't define anything. Okay, so we talked about this runnable and the other stuff. Maybe look at this one, swing constants. Sometimes some interfaces include only constants in them. Okay, so if you implement this swing constants interface, you don't have to implement any method because this interface doesn't include any methods in it, okay? So all you are gaining is just a number of constants. In this 7 constants, it is related to graphical user interfaces, okay? You get lots of constant definitions, such as the codes for the colors, okay? Okay, left alignment, right alignment, constants, and etc. Okay, in fact, let me try to go there and find it. What happened? It is reloading it again. Why can't I make a search here? Overview. Java swing constants. Java. I think it is under AWT. Yeah. Let me go back and let me type it from the search engine. Okay. Okay. Here is the swing constant interface. And as you say, there is a static integer for bottom, center, east, horizontal, etc. These are all constants. They are used as a flag to show some preferences of your graphical user interfaces, such as Windows. So these are some regarding the position of the windows. Okay. So those are the constants that you will need to position a window. And I was wrong when I said maybe the color definition and etc. Okay. So that's it. So if you implement this interface, then that means that you don't have to implement any methods, but you are inheriting all the constants from this interface. So you can use them like your globals. Okay, you can use them like your globals. So what did we say about globals in object-oriented programming? We say that we don't like globals, but Swing constant contains lots of globals. If you like to use those globals, then you implement them. So those globals are not actually globals. They are not accessible from anywhere. It is only accessible if you are implementing Swing constants. Okay, if you are implementing only the Swing constants. So it's a nice way of restricting. It's a nice way of restricting your global scope. Good. And as I said before, there are many interfaces like this, and we are going to look at some of them from time to time. Okay, any questions so far? Again, I cannot read your chat messages if you are writing any. Okay. I'm trying to see if I can read it from the other window. Oh, okay, I have seen one. Okay, so Hussein Ömer has found an explanation why maps are not part of the big part of the collections hierarchy. It's because the maps need the key value pair, and standard collection doesn't allow that. Okay, collection interface was not used in map interface. Okay, it builds a separate hierarchy for the same reason. So the idea of collection doesn't require keys. Maps has to have the keys. Remember the associative containers of STL? It's the same thing. STL, we don't have any inheritance. Okay, we don't use inheritance in STL. They didn't decide it because they were kind of concerned about efficiency issues of the inheritance. But in Java, they don't have such concerns. Okay, good. So let's go back and let's continue our discussion of Java stuff. Exceptions. Okay. The meaning of exceptions are very similar. The mechanisms of exceptions are actually very similar. we like to keep the error handling code from the regular code of our programs so that we can concentrate on the regular part, and later we write the error part, okay, error handling part. This is good for error handling organization. Also, it is good for our program efficiency too. Remember how we write the exceptions? We do this. We say that, okay, I will try, let's say I have a class string as new string something something, and scanner sc new scanner dot, and I do some stuff s dot m1 dot, then scanner dot m2, whatever it is. I do many stuff in here, and I never think that in this loop an error is going to happen. Well, errors could happen. If you look at the string methods would say that if you do that and that, I will throw an exception. If you do this, I will throw an exception. The same thing is for the scanner. Scanner documentation says that if you do such and such, I will throw an exception, etc. Okay, but I don't care about them in this try part. All I do is at the end of my program, at the end of my try block, I would go there and I will go to the documentation of for example, scanner, okay, scanner, and I bet there are many exceptions that the scanner can throw. Okay, so there are 58 throws statements in here. Let me go to, okay, for example, this one. Illegal argument exception. If you don't provide the right name for the scanner, it is going to throw this one. So what should I do? Maybe I should write illegal, what was the name again? Illegal argument. Okay, illegal argument. I handle this, and catch another one. What else? File not found exception. If I'm doing with the files, these are all about the scanner constructors. Let me find some other stuff for the other scanner throws that can come from the, okay, let me find next int. I think next int has a, okay, send next int. Okay, next int can throw illegal state exception if scanner is closed. Okay, or maybe no, this is not next int. Okay, next int is this: illegal state exception or input mismatch exception. I am expecting an integer and somebody's giving me a string, for example. Okay, so that will produce an illegal mismatch exception. So I would write that here too. Illegal input exception and I handle that too. So that's the idea, right? So at this part I don't care about the errors, but this part I am very careful about the errors, because any error can happen with the code. I will handle it. This way my code is nicer, much nicer. Also my code is faster too. Can you tell me why? My code is going to be both nicer and faster compared to the other way of handling errors. Remember what was the other way of handling errors? You call a method and you will say if result is -1, then handle error. Okay, so this was the other way of doing stuff. Can you see why this one, the try catch, is faster than this one? That's because every time I make a function call or I create an object, I need to check if I did it right. But this one, I don't do it. If there is something going wrong, okay, then immediately I will catch it. And I don't have to check. I don't have to check no errors. Okay. So the same mechanism is in Java, and we use throws. Okay. Let's see one example, a very simple example from the slide set. Okay. This program is divide by zero exception handling .java and the name of the class. I have a method quotient. It's going to divide numerator by denominator, like that one. But this one can throw an arithmetic exception. It looks like if for the Java, if this denominator is 0, it throws an exception. So this statement, the division statement expression, throws a exception, and I am not catching it. So my method quotient can throw an exception. Okay. So let's look at this main. Main says that I have a scanner. Okay. And there is a Boolean loop. Inside this is a do while loop. Okay. I will get, it looks like I am going to get two integers and I will divide them. So numerator is scanner next int. Remember, next int can throw some exceptions. Okay. And one of them is input mismatch exception. Okay. Okay. One of them is input mismatch exception. The other one is something to do with the input itself, the scanner itself. So I will ignore these two, but I will handle that one, input mismatch exception. So this one can throw an exception. This one can throw an exception. Also, this one can throw an exception, and I will need to handle all of them. So this part of the code is nice code. Okay, from line 24 to 32. Okay, I don't care about the errors. I always expect that the user is going to give me integers, and I always expect that the denominator will never be 0. So I will divide them. I will call this one. I will print the results out. That's what I do. But if the scanner doesn't work right, I will catch it from at this point, line 34. And I will say that I code an exception, input mismatch exception, and I will print whatever the message is it has using its toString method, and then I say that enter me something right. And if this did not happen and arithmetic exception happened, then I will say that denominator cannot be 0. That's it. Okay, that's it. So the idea of exceptions are exactly the same, no difference. Okay, of course the exceptions, the types of the exceptions and the names are different. Okay, so let's continue. Let's look at, note that in this example I did not throw an exception. Okay, I showed you that there is a throw list, like in C++, throw list available. It says I may throw an arithmetic exception. There is a throw list. I showed you this, but we did not show you how to throw an exception. and we are going to do it right now. Okay, so we are going to use the throw statement again. It is very similar to C++. Okay, so this is what we are going to see using exceptions.java. Okay, using exceptions.java. My class name is using exceptions, and this is my method main. Okay, my method main calls two methods. One is throw exception, the other one is does not throw exception. These two methods I will write in a few minutes now. Okay, I will show you the implementations of those. This one throws an exception. It looks like it is throwing an exception of type exception. In Java, we have the exception hierarchy like in C++, but the Java exception hierarchy is much more detailed than C++. Okay, let me show you the exception hierarchy of Java. Okay, exception, okay, class is this. It says that I come from throwable, my name is exception, and I am a serializable, I am implementing this. And all of these are subclasses of exception class. There are many exceptions, standard exceptions, okay, in Java. And let me try to find the graphical versions of Java exceptions. Okay, there it is. It is better if we have something visualized. Yes, that's it. Okay. I don't see everything here. And this one is talking about the errors, and yeah. I didn't like this one. I think this one is better. Well, I think it is doing the same thing. Okay, this exception side is larger now. There are many exceptions in Java, as you have seen. Yeah, exception hierarchy. Okay, so these are the exceptions: runtime exception, IO exception, SQL exception, abstract window, toolkit exception, etc. So the arithmetic exception, remember this one, we used it. Null pointer exception, class cast exception. I think we have seen examples of these. Okay. What about this illegal argument exception? I don't see it here. So this is not a complete hierarchy. So let's go back to our code. In our code, I am saying that I am catching something of type exception. So I am catching of the superclass exception. I should be able to catch everything as long as they are subclasses of it. And I print this error message, and that's it. So let's look at the implementations of these two methods. Throw exception is here. Throw exception says that, it's a very stupid example again. In the try block, I print something and I'm going to throw an exception. Just an empty exception. As you see, the throw list says that this throw exception can throw an exception of type exception. It throws an exception and it catches it. Again, if somebody is throwing an exception and catching it, they are doing a very stupid thing. Don't do that. These are for demonstration purposes only. So it throws an exception, it catches the exception, it says that I caught an exception, and it throws the exception again. Okay, it throws the exception again. And who is going to catch it? This time nobody is going to catch it. This method throws an exception. So every time you call this method, this method is going to throw an exception. Now we will see a new thing here, final block. In Java we have try, catch, and finally blocks. Okay, in C++11 we have this too. I didn't talk about the finally part, but I am now talking about for Java, and you can apply the same technique to C++11 too. Final part is this: whatever happens with the try catch block, okay, final part will definitely be executed. Okay, try block could throw an exception. If the try block throws an exception, catch will catch it. Try block may not throw an exception. Remember my example. Okay, let me make this a little bit smaller so that I can write some more stuff in here. Okay, so there is try block and there are catch blocks, and now we are saying that there is a finally block. Okay, finally doesn't take any like the catch parameters. Finally does this. Okay, this part can throw exception. If it throws an exception, they will be called. This part may not throw an exception. In that case, catch part will not work at all. But whatever you do, this part throws an exception or not, okay, whether the catches them or not, final block will always be executed after this block or after each of these catch blocks. That's the meaning of finally. That's the meaning of finally. Good. Okay, so we have the same thing available in C++ too. So let's go back. Okay, and let's look at that finally thing. Finally says that system error finally executed in throw exception. So in this case, if I call this throw exception, it will throw an exception, it will be caught, and it will be rethrown again. But before this method ends, this line 40, will be executed. Doesn't matter if I throw exception or not. In this case, I throw an exception. Final block will always be executed. What would I put in my final block? Any ideas? What would I put? What would I put in my final block? By the way, finally is optional, of course. You don't have to write finally. But if you are writing finally, what would you put in it?
Some print stuff.
Some what stuff?
Print.
Yeah, explain that a little bit. What do you mean print?
For example, program is closed or something like that.
Oh, you mean, okay. But I mean, you are assuming that an exception has happened, right? So if you are going to do that, I mean, if you are going to say I got an exception, okay, I got an exception and I'm terminating the program, you would do that in the catch part, right? That's what you have assumed. An exception occurred, so you would put those kind of messages in the catch part because you know that an exception occurred. Final part is whatever happens, okay, whatever happens, it will be executed. So what would you put in the final part?
Maybe garbage collector?
We don't do the garbage collection ourselves in Java. It will be done automatically.
But there was a method named as GC.
Well, we don't use it much, because we use it just to show you how the finalize works. Usually we don't call it. We don't think about the garbage collection in Java much. Maybe for your whole Java developer's life, you will call it once or twice.
Closing connections.
Maybe closing connections. If this throw exception method opens a network connection, opens a database file, okay, before this method ends, I need to close that file. I need to close that network connection. I need to do some bookkeeping, right? Okay. Regularly, if everything goes right, I am going to do them in my regular try block. But if I throw an exception, my files may stay open or connection may stay open. Okay. So I need to do some stuff and I'm doing that in the final part. Okay, good. So this is the method that does the throw exception stuff. Okay. But remember, this main calls this throw exception. And in that case, throw exception is going to throw an exception. I will catch it. So I am catching the same exception 2 times. I throw it, I caught it, okay, and throw it again. And I catch it. I am catching it here. So I caught the same exception. Okay, I caught the same exception 2 times. And let's look at this does not throw exception method. As the name implies, it is not going to throw an exception. And that's why we don't have a try catch block around it. Let's look at the implementation. Implementation is as simple as this. Does not throw exception. Okay, try system out print line doesn't throw an exception. Well, in case it throws an exception just for demonstration, it catches an exception, and I print this statement on the screen exception. And I have a final block. Final block will always be executed. Okay, so tell me what happens when I call this method. Tell me what happens when I call this method. First, line 53 will be executed. Then what? Then which line will be executed after line 52? I executed this line 52. Then then what?
60.
Then it will execute line 60 and 61, right? Finally, why? Because I did not throw an exception, so this one will not be executed. And then what?
64.
64 will be executed. So this one will print method does not throw exception. So this one 52, and this line comes from 60 and 61, and this one comes from 64. Okay.
Can we return something in final block? Return 5 or something like that.
Yes, you could, but that would be a bad thing. Why? Because usually you end your methods in the right way. After the try catch block. Okay? after try-catch block. You return something at the end of your try-catch block. You could do that, but usually inside your try-catch final blocks, you don't return stuff.
Okay, sir, thank you.
Okay, good. So the same thing is available in C++ 11. And the syntax is something like C++ 11 finally. Oh, okay. How did it know that I am going to write it? That's scary.
They are watching us, sir.
Well, I kind of suspect that too. Okay, so where is this example? This is, oh no, I am going to go to the standard documentation, C++. Okay, so C++ 11 compiler is needed for this code, it says, because before that we didn't have the, okay. What? Try, catch. What is this? It's using a final class. I couldn't find it, sorry. I don't want to spend time. Okay, you look it up, okay? Try final statement, is this C++? From Microsoft? Okay, try and finally. I couldn't find the right documentation. You look it up, okay, and you will see that the same thing is, I mean, concept-wise, the same thing is in the C++ 11. Good. Okay, so that was the exceptions. Any questions about exceptions in Java? Are there any questions? If there are no questions, then I will talk about generics in Java. Generics are kind of templates, but they are not exactly templates. Due to Java's virtual machine stuff, okay, and special compilability and interpretability features, they did not do the templates as we have in C++. Instead, they produced this concept named generics. And Java, even though it was designed much later than C++, it did not implement generics for a long time. Later they gave up and they decided that they are implementing it. Previously they were saying that they don't need templates because they have this object hierarchy. Everything comes from the object. So whatever you write, actually, you can write them on objects, and later you through the polymorphism, okay, they say that, okay, sort, right? A sort method. If I have a sort method, then I would write this sort method on an object array, okay? And if the objects are right, the sort will work. So if I can write such generic functions, why do I need the templates? That's what they were saying, okay? So their solution was, pass me an object array, and if they have the right methods, I will sort it. So during the runtime, they were checking if the objects are right. But once you realize that these templates instantiation is happening during the compile time, and it is producing very efficient code, they say that, okay, we are going to support something, but we are not going to call it templates. We are going to call it generics, okay? And that's what the generics are. Okay, they provide compile time type safety. You don't say, okay, I have a sort method that sorts the objects. you will say, I have a sort method, a generic sort method that can sort the templated arrays, and we are going to see it during the compile time. I will produce those methods automatically. Okay, so we have both generic methods and generic classes. Let's see one generic method example here. But it looks like I need to take 5-10 minutes of break. Let me put this up. Let's take 10 minutes of break. Let's be here around 9:30. Okay, people. So this is our first example of a generic method, not class method. Let's say I have a print array method, array of elements, and I like to print these elements to the screen one by one. Okay, all you do is I have a print array method. You say it's a void returning method, public static method, and you put this generic parameter name at the beginning of the method header with these angled brackets, less than sign E and greater than sign. So that means that your method generic parameter is E. Okay, so I am taking this. So the corresponding C++, okay, function would be template class E. Then you would say I have a static, void print array, and my parameters are again, this is E. Usually we would get, since it's a print array, I would say constant E pointer input array, and I implement it. Okay, so remember at the beginning we put this class E expression at the beginning of the template definitions. This time we don't use this keyword generic or template. We just put this E in front of this returned value type. Okay, public static E void, and I continue implementing my method as usual. Instead of using a regular types, I use this E type, and then I have arrays of integers, doubles, characters, or strings, doesn't matter. Okay, these are my arrays, and I can call this print array on any of them: integer array, double array, character array, money array, gradebook array, or string array, doesn't matter. Okay, and it will work. As soon as the compiler sees this line, again, this generics are compile time thing in Java too. As soon as the compiler sees this line, it will see if are there any print array methods. No. Can I produce a print array method using the generic definition? Yes. So it will come here and it will do that. Okay, it will produce it for the integers. By the way, the generics can work only with reference types. Okay, they works with reference type. You cannot have a generics of int. That's why they have this integer class. Okay, what was integer again? Int is a primitive type. It's not a reference type. Integer is the type, reference type that corresponds to int. Okay, so you cannot make an integer without using the new operator. You need to use the new operator. Okay, you will say integer I new integer 2, something like that. Okay, but how come you did not use any new operators here? because I created 1, 2, 3, 4, 5 integers. Okay, well, this is a special notation. Remember at the beginning of the Java discussions, I said that there are ways of creating objects without using the new operator, especially for the string. The same is valid for the boxed primitive types too. Integers, doubles, characters, booleans, etc. Okay. Okay, so these are the box versions of the primitive types. Let's go to the documentation of the that boxed integer class. It's a very simple class, and you will see that okay, it serializable. I can write it to the disk network, and it is comparable. It comes from the same superclass number. Okay, and these are the static constant static final data members. Max value, min value, size is the number of bits. Okay, and this is these are the fields. Constructor is just constructor. You can construct an integer from an int or from a string, and these are the methods. How many bits in there? Byte value, okay, as a byte. There is this compare method. Compare to is, of course, this is comparable. And decoding from a string, I can convert it to a double. Equals is from the object class. Float value like the double value. Okay, I can get the integer. I thought it was going to give you the integer with respect to some base value, but it is not. Okay, hash code is from the object again. Int value is here, long value is here. Whatever what method you look at, you will never see any methods that changes the value of integer, because integer or double or boolean or those boxed versions of the primitive types are not mutable. They are immutable. Okay. Good. So there are many methods. ToString is here. There are many methods of integer, and I think there is a ToString. Is there such a thing as value of string? Yeah, returns an integer object holding the value of the specified string. You provide a string and it returns an integer for you. Okay, so this class is a box class, and you could use these kind of classes to represent your primitive types. Why am I talking about this? I am talking about this because, as I said, generics don't work with primitive types. If you say I have an integer array ARR dot whatever it is, okay, 5, 6 elements, and when you say print array ARR, you will get an error message, because generics don't work with the primitive types. These are some of the restrictions of generics. Other than that, it will work, no problem. And as you see, it will work for the integers, doubles, and the characters. The nice thing is with this print array method, since remember we had this concern when we did the templates, we said that templates will not work for some of the some of the template parameters because the functions are not available. This function, this print array, will work for any kind of class because I know that all the classes, all the objects should have a toString method. Okay, and toString will convert my objects to string and it will work. Okay, good. Any questions about the generic methods? Any questions about the generic methods? Anybody? No? Okay, so if there are no questions, okay, let's talk about the generic classes. Generic classes are very similar to generic methods. Again, let me show you an example from the web. Where is it? Okay. Before the generics, this is what they used to do. Okay, I have a class. As you see, this is a regular class. This is generics type old. Okay, whatever you do, you will say that you don't say that I have a money object in me. You don't say that I have a gradebook object. You will say that I have an object. Okay, I have an object. And your getter will get the object and your setter will set the object. Okay, that's it. Okay, and when you make a new object, you will say I am making a generic type old object, and you would set this one with some string. Okay, it looks like this guy is going to use this t as a string, and you would get something. This get would return a object, and I would typecast it to a string, right? Because I know that I set a string to it. But if I set something else to it, it will work too. So I have to do lots of runtime type checking. Typecasting error prone and can cause class cast exception. Okay. If let's say instead of writing string here, instead of writing string here, if I say double, okay, it will cause a typecasting class cast exception. That's not good. So this is what they used to do before the generics. Okay, they say that since everything is object in Java, I don't need the templates or generics. I can always do this type checking during the runtime, but that's inefficient and error prone. So they came up with this idea of generics. This is generics type, okay? Public class generics type and angled brackets t. You don't use the keyword generics in Java. That's what you do. It's very similar to writing C++ templated class code. So you have a private field of type t, okay, and your getter returns a t, your setter gets a t and sets it to t, and when you say I will now have a generics type, okay, string, that's good, and you will say new generics type string, and you put a string in here. Actually here there should be a string, and I would set a string to it, okay, and you would use it that way. Okay, that would be my generics class. Also, you can have the generics interfaces too. Just a generic interface, a comparable. See, the implementation of the comparable interface is actually a generic interface, and in that case you say that I am a comparable interface of type t. Okay, so this comparable will work for everybody. Okay. So that's the idea of using generics in Java, and the whole collections hierarchy is generics based. Okay. If you look at any Java array list, okay, if you look at any collection class, you will see that they are all using generics. It says E, okay? So array list of type E, and serializable, clonable. Array list is not comparable, right? It is not comparable, but it's clonable, serializable, iterable, and it's collection again. And it depends on this E. I can have an array list of anything. But again, you cannot have array list of primitive types. No. Okay? You cannot have an array list of integers. This is an error. Array list int is an error. Okay. Instead, what should I do? I should do array list integer. So this unboxing should happen between int and integer, if you like to use integers. This is what's happening here. These are ints, but due to this boxing happening, each one is converted to an integer. Okay, so that's it about generics. And to study some generic classes, you just read about the collections, and I showed you how to use them, how to find the documentation for those generics. Any questions? Mehmet, you have a question?
Yeah, hocam, I didn't understand why it's inefficient to use object classes instead of generics.
Why is it inefficient, you are saying? Okay. Well, I mean, as the code here says, where is my code here? Okay. You mean this? Why don't we use this, you are saying, right?
Yeah, yes.
Okay. Because every time you do a get, you need to do typecasting. Okay, and you need to make sure that you didn't cause any class cast exception. Okay. Every time you do this get or set, you need to make sure that the type is okay. And you have to do all of this checking during the runtime. And other than that, it causes lots of problems when you are writing the code. You have to make sure that you are using the correct type. Whenever you get anything, okay, remember, that was the idea of, remember our class object, Java class object. Where did it go? Okay, remember our Java class object. Java class object is written before the generic stays. Okay, and as you see, this equals takes an object parameter. Okay, what was the first statement of equals? What did I say? I said that it should check if the object that I received as parameter is the right type, right? So that there is an if statement there, right? Every time when I call this equals, I have to spend that time for the if. This one doesn't use generics. Okay, this one doesn't use generics. But if I use the generics, remember Java comparable interface, Java comparable interface uses compare to method, and comparable is a generic type. Okay, it uses T. This compare to doesn't check if the type is right. because I know that the type has to be the correct because I verified that during the compile time. Otherwise, I did not compile it. Okay? So compiler makes sure that whenever a method is called, the types are right during the compile time. That's why they call this, I mean, in Java, they said that, okay, we are giving up. We are going to be more efficient. Okay. We are going to provide compile time type safety. If you check your types during the compilation time, it will be efficient for the runtime. Otherwise, you will have to do the same thing, type checking during the runtime. Does this make sense?
Kind of.
So what is your problem?
I mean, I think I have to repeat those topics again.
You mean to read it again? Okay. Okay, you read it. And the idea is this, okay? If you are writing non-generic code using the objects only, this is like always using the void pointer, to point to something in C++. This is possible, right? Instead of using any pointer types, you use just void pointer, and that's it. Then you should be fine, no problem. You could do that, but every time you need to convert that void pointer to money pointer or a gradebook pointer or partially filled array pointer, you need to make sure that your pointer is right. You are pointing to the correct elements and etc. So it is possible to have a completely typeless system, and this is using objects only, like that one. Using objects only to represent something is something like that. You have to do lots of work during the runtime to make sure that the types are okay. Okay.
Thank you.
Good. So, are there any other questions about Java or generics or anything that we talked about? Again, Java and C++ are very similar. Java is designed in a way that we are going to modify C++ syntax to make it more object-oriented programming language. Also, during the motivations of the 90s, we are going to have a completely compiled code level portability. Okay, we are going to achieve it through the Java virtual machines, and we are going to eliminate lots of complicated stuff about C++, such as operator overloading, the differences between references and the pointers. Let's not use the pointers, let's use the references, smart pointers, and etc. So it got popular and people have been using Java a lot. There is a very large amount of libraries written for Java. But nowadays the situation is getting a little bit more different. There are other programming languages like Python that is easier to use, easier to learn, very, very fast to very quick to start. Okay. Anybody can start doing some experimentation with Python even without knowing much programming knowledge. Okay, and there is some nice amount of libraries written for Python too. So it looks like Python is replacing kind of Java. Okay, and Java is faster than Python. And C++ is faster than Java. So the initial promise of C++ is still there. Okay, I am flexible and I am fast. Okay, Java says that I am not that fast, but I am easy to work with. But there are other programming languages that are easier to work with. They are slower than Java, but I mean, if you like to go to one end, at the one end there is definitely C and C++, being efficient and flexible. At the other end, it is not Java anymore, okay? The other end is some other programming languages. That's why at the beginning of the semester, what did I show you? I show you the what was the name of the institution that keeps the programming languages? Okay. TOB. Okay. This programming language index says that, okay, January. Okay, so C is again number 1, Java is number 2, Python is 3, C++ is 4th. So Java and Python will switch places maybe. Maybe Python is going to be number 1. Okay, so what is this? The first one is C. For some reason C went back and came back up. And Python, what is this? This is Java, okay. Java was at the top and it is coming down and it will go up again, but you know the trend, right? You see this black, you see the tendency of the black curve? It is going down. You see that, right? How about C? C is kind of straight, but Python is getting more and more ground. It is going up. C++ is kind of flat. Okay. So what I'm expecting is, again, C and C++, they are still solid programming languages. All of them are solid, but C and C++ will keep their promises. And Python is going to catch up with Java. Maybe it will replace the number 1 most popular language. But later, I am sure people will find other programming languages to replace both Java and Python. Okay, so that means that always be prepared. Always try to learn new programming languages such as Python. Okay, good. Okay, let me go back to my slides. I am going to start Java said that, okay, this graphical user interface stuff, C did not care about it much. It didn't make C or C++. They didn't make the graphical user interfaces standard parts of their languages. But Java says that no, I am going to make the graphical user interfaces standard parts of the language. Okay, I will support them by the standard libraries, and I like to show you a few examples of it today and on Monday. On Monday I will make a makeup class. Okay, on Monday we have a class in the morning at 10:30. Makeup class on Monday 10:30, and I will talk about the graphical user interfaces. The purpose here is not just to show you the graphical user interfaces, how to make the graphical user interfaces. The purpose is actually, let's study a properly designed, carefully designed Java library, and let's see some Java code actually. So by studying graphical user interfaces, I get the opportunity to talk about some Java code. Okay, so some basic graphical user interface components of Java: JLabel, JTextField, JButton, JCheckbox, JComboBox, JList, JPanel. Each one is used as a pluggable component of a graphical user interface. What do I have as a graphical user interface? Let me show you one example. Okay, open up my Chrome browser. Okay, Chrome browser has a very nice graphical user interface. Okay, it has lots of labels. For example, these are labels. Okay, also these are the buttons. These are buttons because I can push them, right? If you can push them, these are your buttons. And then I have what? I have pull down menus like this one. If I click on one of them like this one, I get a pull down menu. Okay, this is a graphical user interface item. I have a panel. Panel is here is this large area. I can write anything that I like on this panel. So designing a graphical user interface is something like that. You will say that, okay, this would be my window. Okay, on my window I will have a title bar. Okay, on my window I will have a title bar, and maybe I will have an OK button here, and maybe a cancel button. I will have a maybe text field here, okay, and then I will have my menu maybe at the top here. So what you are doing is each one is a component. Each one is a component, graphical user interface component. I just make objects of these components and I put them on my window. So graphical user interface programming usually means creating lots of objects of these components and putting them in some kind of a container. Okay, so in some cases whatever available will not be enough for us, so we will make our components by using these components either through composition or inheritance. Okay, so you might say that I like JPanel very much, but JPanel has something missing. So I will extend a new class, okay, using the JPanel as a superclass, and I will add this property to it. So it will be your JPanel. So JPanel is a very complicated class. It will have tens of thousands of lines of code, but all I need to do is just a few lines of method to it, and that will make my panel. Okay, so we will do this in a lot of places. While doing this, I get the opportunity to talk about inheritance, composition, Java programming, and etc. Okay, that's why we are looking at this graphical user interface components. Also, for me, it is fun too. Okay, you get to see some other than black and white stuff. You will get to see some colors. Okay, so let's first example. We are going to do this. Okay, we are going to write a program that will show you such a window. This window will have this minimize, maximize, close buttons, and when I come here and push this end, I can resize it. If I resize it, it again draws this cross, two lines, just from this corner to that corner and from this corner to that corner. Whatever I do, whatever the size it is going to be drawn on that one. So that's the first program, graphical user interface program, that I am going to show you. As always, it's going to be a stupid program, but nevertheless, it's going to be our first GUI stuff. So let's see what's going to happen. So remember the JPanel. Okay. In graphical user interfaces, there are two things. There are frames like çerçeve in Turkish. It's like a painting. Yağlı boya tablosu gibi. It's like a painting. What kind of components does a painting have? It has a frame, çerçeve, like this one. And it has a panel. Like ne diyorsunuz o çerçeveye geldiğiniz şeye, kumaşa? Tuval mi diyorduk? Tuval mi diyorduk?
Yes, sir.
Tuval or panel, okay? So what I'm going to do is I will make my own panel, okay? And on that panel I will draw some stuff. This is how you do it, okay? Java already has a panel class, JPanel class. Okay. It is under Java extensions Swing panel. Okay. I am going to extend it. So I am doing the derivation in terms of C++ terminology. Okay. I am extending JPanel class. And while I am extending JPanel class, all I do is I just override this paint component method. If you have in Java, if you have a panel, okay, that panel can handle itself. It doesn't need any help. But if I like to do something that I want with panel, okay, I need to override this paint component. This paint component method is called automatically by the Java Graphical User Interface Management System. Okay, so it is called automatically. I will never call this paint component myself. Paint component is something like that. Java tells you that, okay, here is your panel and here is your pen or your painting brush. Okay, that's the graphics object. Here's your panel and here's your painting brush. Okay, you may override this, and whenever I need it, I will call this paint component to paint the frame. Okay, paint my panel. So what is my purpose? My purpose is draw two lines like this and that on the panel. So this is how I do it. First, I said that whatever you are going to do with the paint component, you do it. Okay, super dot paint component. It will be handled. Okay. Then I say that what is my width and height? What is my width and height? Okay. Panel has a width and height, right? And I don't know that. Okay. I get that one. But it looks like I am calling some global methods, right? Get width and get height. Where do I get them? Who defines get width and get height?
JPanel.
Exactly, JPanel. Inside JPanel, get width and get height is defined, and I am calling them. Let's go to the okay, JPanel class, and you are gonna see that it's a complicated class actually. Object, component, container, component, and JPanel. So that's the hierarchy of JPanel, and we are extending it. And if you look at all the methods available, okay, for JPanel, it is this. Okay, methods inherited from the J component. These are my methods that I inherited. These are the methods that I inherited from container, then the AW component. These are the methods that are inherited from object. And these are the methods that JPanel defines. So let's see where this get width is defined. So it looks like get width is coming from J component. Okay. Get width is coming from J component. So I am calling J width. Okay, get width, and I'm calling get height. Then now I am going to draw these two lines. Okay, to draw a line, you get this graphics object. Okay, graphics objects are used for drawing stuff on your GUI windows. You say that, okay, I'm going to draw a line on this with this object. In Java coordinate system, if your window is like that, okay, this is your coordinate 0, 0. This is your coordinate 0, your maximum width. Okay, this is position, your maximum height 0, and this is the position. I am doing it wrong. Okay, this is W0 width and okay, and this is 0 H, and this is WH. So I got the width and height of the window, and I am going to draw a line first from this position, 0, 0 to width and height. So this one draws this blue line, draws the blue line from 0, 0 to width and height, and this one will draw a line from 0 height. Let's do it with the green one, from 0 height to width 0, like that. Okay, and that's it. So I have a panel that can behave like that, but this is only a panel. I don't have the frame yet. Okay, and I call this a draw panel. So this is drawPanel.java. Let's write the main method that will use this draw panel. So I need to create a frame to put this panel on, and I will let the frame be displayed on the screen. Okay, here it is. My main is contained in this draw panel test. Okay, and I say that I have a new panel. Remember my class draw panel. Okay, and I have a new JFrame. I am not inheriting anything from JFrame. I just make my frame. It's just a çerçeve in Turkish. Okay, and I am setting some operations on it. I say that, okay, I am setting the default close operation to exit on close. If somebody clicks that red button here, okay, its default behavior is now closing. Now I add my panel to this frame. My frame is something like that. Okay, my frame is this. Frame is this part. This is my frame. Okay, that frame includes the minimize, maximize, close buttons. Also, there is a small menu in here, right? Okay, that's the frame. So I will add my drawable panel to this frame, and I set the frame size to 250 and 250. That means that this window at the beginning, the height and width will be 250 pixels and 250 pixels. And now I make my frame visible, and I end my program. So this is weird, okay? I don't see any loops in here, right? I don't see anything. I mean, I didn't call my draw panel paint component. I didn't do anything. After I did all of them, I just end my main program. So I created this window, but I didn't do anything else. So it looks like after I end my main method, this would go away, right? Because my program is ending. No, it doesn't go away, because I am using this complicated Java GUI management system. Okay, this one, when I say set visible, this one creates a thread, a parallel program. It runs by itself, and that program is going to run until I hit this red button. Okay, so my main method only created this window, and my main has ended, but my other thread is continuing. Okay, so the program, the client, the user of my program can resize this one, minimize it, maximize it, do all kind of stuff, and it will obey. And when the time is right, when the time comes, they will hit this red button, and this window will go away. Okay, so this is our first graphical user interface program. It didn't do anything useful, but it showed you kind of idea. So total of how many lines? Total of 22 lines in here, and 22 here, like less than 50 lines of code, and I can do such a kind of stuff. Of course, I didn't do everything myself. I extended a class, and I used an object of another class. There is lots of details in it. I mean, you looked at the methods of the JPanel, right? And JFrame is as complicated as JPanel. And mastering all the details of this, all these documentation, will take lots of time. And nobody is expected to remember all the details of this stuff. That's why GUI programming is something like you do it with lots of documentation. You go back and forth, okay? And sometimes you use help from other tools, like you don't do everything by coding, but you get help from the GUI designing tools, okay? You design your GUI using some graphical interfaces, and they write your Java code for you, okay? Good. Okay, any questions? Any questions? So it looks like this is interesting. What kind of other stuff do I have other than the drawing lines? Okay, graphics object, draw line. Let's go and let's try to see what else we can do. Java, Oracle, graphics. Okay. Yeah, this is the graphics class. Graphics HTML, and draw line will be one of the draw. So there are 191 draw. Okay, draw line is here. Okay, you provide the one corner of the one end of the line and the second end using X and Y coordinates. Okay, other than the draw line, what do I have? I have draw oval, like ellipses, draw polygon, draw rectangle, draw round rectangle. I can draw strings. Okay, what else? I can draw images. I can draw arcs, etc. There are many stuff. Yes.
Do we have draw points?
Draw point? What do you mean point? What is a point? A dot?
Yes, just a dot.
Well, you would draw an oval, a filled oval maybe. Okay? Where is my draw oval? Draw. Yeah, draw oval is here. So you will say that at this position X and Y, draw me an oval with this width and height. Okay, that will give you a point, and you can make your point as large as you like. I don't know, maybe there is a one. I don't know. Maybe you could do this. Draw character. Where is the draw character? Draw chars. Okay. Okay, draws the given text by the specified character array using the graphics contents of the current font and color. So you just draw a character, okay, dot character maybe, at that position, okay?
Thank you, sir.
I don't know, I mean, how many methods are there with this graphics? Okay, close to 50 maybe, okay, close to 50. So let me show you one example, and on Monday I will start doing this. I will start, okay, I will, okay. How can you do this? I'm not going to show the code. Let's look at this one. How can you draw such a thing? This is definitely 0 and 0, right? This is 0 and H. This is W and 0. If I like, I can draw a line between here to there. If I like, I can draw a line between here to there, right? How about this one? What is this? Draw from 0, 0 to what? What is the coordinate for this one?
W over 2 and H over 2.
Yeah, W over 2, comma, H over 2. Okay, so it looks like I would write a loop that will start from here to until it gets here. So while I am doing this, I am decreasing the height part and increasing the width part, and right, doing that. And this one is first, it is doing, I guess it is doing first this one like that, right? Then it does maybe it does this. Okay, and then after that maybe it will do this blue stuff and the other corner, and it produces this nice shape. Okay, how about this one? Okay, you figure this out. That's it from me today. I will continue on Monday.
Sir, when will our final exam?
I don't know. The department or the dean will, the faculty will announce it.
Thank you, sir.
Okay, see you on Monday.
Can you share the slides?
Sure. Okay, just a minute. So these are the slides that I am using right now. Okay, and these are the slides that I'm going to use on Monday. Java slides. Okay, you got it? Did you get it?
No. Yes, we got it.
Okay. Okay, see you on Monday.